We've all been there, right? You get this idea you want to give your virtual machines that extra edge, like thinking, man, if only these VMs had the power of a dedicated graphics card, for gaming, for rendering, all that good stuff. That's the beauty of GPU pass-through. But, it's not exactly a walk in the park, is it?
Not always. It's
Yeah.
definitely a bit more involved than just plugging in a graphics card and calling it a day.
Exactly. And that's why we're here today to do a deep dive on one crucial piece of this puzzle, the IOMMU, or Input-Output Memory Management Unit. Sounds intimidating, right?
It does, but trust me, once you grasp the concept, it all starts to click.
Okay, so for those of us who didn't grow up dissecting motherboards, what exactly is the IOMMU?
Okay, imagine this. Think of the IOMMU as a conductor, right? Like a conductor in an orchestra. It's this component that manages all the different parts of your computer system, making sure that everything's playing in sync.
So it's keeping things organized, especially when we're talking about something as resource-intensive as giving a virtual machine direct access to a physical GPU.
You got it. It's like giving each musician their own dedicated instrument instead of making them share.
Makes sense. So in the context of GPU pass-through, the IMMU is making sure that the virtual machine and the dedicated graphics card can, actually work together. No fights over who gets the bandwidth.
Exactly. But, and this is where things get really interesting, sometimes your system might lump certain devices together. Even if you have, say, two physical GPUs you mentioned, wanting to use an NVIDIA RTX 2060 and an AMD Radeon RX 7600, right?
Yeah, that's the dream team.
Right. Well, your system might see them as one big, happy GPU family, even if you need them to be in totally separate rooms. These are called IOMMU groups.
Ah, so even though I've got two separate GPUs, my system might be treating them like one big GPU party. And that's a problem if I'm trying to, say, run a Windows 11 virtual machine and an Arch Linux virtual machine at the same time, each with its own dedicated graphics card.
Exactly. That shared resource pool becomes a bottleneck, like trying to fit a whole orchestra on a single bus.
So if we run into this IOMMU grouping issue, what's the first thing we should check before we start digging into the really complicated stuff?
First things first, have you checked for updates recently? Specifically, BIOS and UEFI firmware updates. You'd be surprised how often a simple update can iron out those IOMMU quirks.
Always good advice. But let's say we've done all that right, updated everything, and those GPUs are still joined at the hip. What's next?
All right, in that case, we journey into the BIOS settings.
Ah, the BIOS. The land of cryptic menus and that slight fear of accidentally bricking your computer?
A healthy dose of caution is never a bad thing. But trust me, there are a couple of key settings in there that can make all the difference for GPU pass-through.
Hit me with them.
First, make sure virtualization is enabled. You'll usually find it listed as VTD for Intel systems or ANEVI for AMD. It's like flipping that switch to let your system know it's okay to share those GPUs with the VMs.
Like giving your VMs the VIP treatment. Got it. What else?
Next up, and this is where having a virtualization-friendly motherboard really helps, is to check the PCIe slot configuration. Those slots, those are the physical homes of your graphics cards. Now, some motherboards, especially the ones built for this kind of stuff, like those AC's Argud's Maximus boards, they give you fine-grained control over how those slots are handled by the IOMMU. You might find options to say specifically assign slots to different groups, giving you way more control over those IOMMU groups.
So it's like, instead of having a free-for-all in one big room, I can actually assign each GPU its own separate space.
Precisely.
Okay, so we've enabled virtualization, we've optimized the PCIe slots, but those GPUs are still stubbornly grouped together. What's our next move?
That's where we bring in the big guns. Kernel parameters. We're getting a little technical here, but stick with me.
Love it. Let's do it.
Think of the kernel as the brain of your operating system, right? We can give it specific instructions, almost like a cheat code, to influence how it handles these IOMMU groups.
Okay, I'm following. How do we give the kernel these cheat codes?
We do this by adding parameters to the grub configuration file. It's like your computer's boot up to-do list. We're basically slipping in a note that says, hey, remember to handle those IOMMU groups this specific way.
I like it. Subtle yet effective.
Exactly. We'll tell it to enable IOMMU, use a specific mode called Passthrough, and most importantly, to override the way it usually groups PCI devices. It gets a bit technical here, but the guide you've been looking at mentions using parameters like Intel IOMMU on, IOMMU on, and if all else fails, this SIAX override. Have you heard of that one?
A SIAX override. It sounds powerful, but also like something you don't mess around with lightly.
You're right to be cautious. That one comes with a bit of a disclaimer, especially when we're talking about security.
So it's like, we're telling our system to relax a little bit, security-wise, to get those GPUs to play ball.
That's a good way to put it. And look, for some people, that might be totally fine. If you're running a home lab, experimenting, and security isn't your top concern, well, it could be an option.
Yeah, you're not running a bank here. It's your own little sandbox. But if it's a work machine or you've got sensitive data, maybe think twice before going down that road.
Exactly. Always better to be safe than sorry. Okay, so we've talked BIOS settings, we've talked kernel parameters. What if, and just hear me out on this one, what if we physically move the GPUs?
Wait, really? Like, physically take them out and put them back in different slots? You're messing with me, right?
I know, it sounds a little out there. But sometimes those IOMMU groups, they're influenced by the physical layout of your hardware. Might be worth a shot, right?
Yeah.
If you've got the space on your motherboard and you're comfortable opening up your computer, of course.
So it's like, we've tried being clever with the software, now we're resorting to good old-fashioned brute force.
Something like that. It's
Yeah.
all about exploring every option. Right?
I like your style. Okay, let's say we've tried everything. BIOS tweaks, kernel parameters, we even moved our GPUs to new apartments. And it's still not working. What then? Do we just admit defeat?
Well, before we throw in the towel, we do have one more option, though it might involve a bit of a platform shift.
Okay, I'm intrigued. What are we talking about?
So Proxmox, it's a solid choice, don't get me wrong. But other virtualization platforms like VMware, ESXi, or Xen, they might just handle IMMU grouping a little differently. It's possible that your hardware, your specific setup, might play nicer with one of those platforms.
So it's not you, Proxmox, it's me. Time to see other hypervisors.
In a nutshell, yeah. It's always good to have options, right?
It makes sense. Okay, before we get too far ahead of ourselves, can we talk about drivers for a second?
Drivers, the bane of every tech enthusiast's existence. What about them?
Well, it just occurred to me, we're talking about dedicating these GPUs to virtual machines, but what's stopping our Proxmox host operating system from trying to use them?
Ah, that's a great point. And you're right to be thinking about that. It's entirely possible for your host system to try and load drivers for those very same GPUs that you want to give to your VMs. It's almost as if your host system wants to hog all the graphics power for itself.
Right, like, hey, these are mine, hands off.
Exactly. And that's where the concept of blacklisting comes in. Basically, you're telling your host system, hey, ignore these specific drivers. That way, those GPUs are free and clear for your VMs to use without any conflict.
So we're putting those drivers on the do not disturb list.
You got it.
Yeah.
The exact process involves a little bit of configuration file editing, but all the details are laid out in that comprehensive guide we mentioned earlier.
Perfect. So we'll spare everyone the nitty-gritty details, but just know that driver management is key here. We've got to make sure those VMs have exclusive access to their dedicated graphics cards, no roommate drama. Speaking of which, before we get too carried away with all this talk of solutions, I think it's important to manage expectations a bit. Not all motherboards were created equal for GPU pass-through, were they?
That's very true. You can have all the right intentions, all the technical know-how in the world, but at the end of the day, some motherboards are just not designed with GPU pass-through in mind. Certain chipsets, limitations in their design, it happens.
So it's like trying to bake a birthday cake in a toaster oven. The limitations are baked into the hardware itself.
That's a perfect analogy. You said it, not me.
So what's the takeaway for someone who's, maybe hit a wall, tried everything, and their motherboard just isn't cooperating?
Don't despair. First off, you learned a ton just by going through this whole process, right? And who knows, maybe tomorrow there will be new hardware, new motherboards that completely change the game. Technology moves pretty fast, right?
It really does. I mean, a few years ago, we wouldn't have even dreamed of doing some of the things we can do today with virtualization.
Absolutely, and that's what makes it so exciting, right? It's a constantly evolving field.
Totally. Okay, so we've gone pretty deep on IOMMU groups, kernel parameters. We've even talked about physically rearranging hardware, but it feels like we've just scratched the surface of what's possible with virtualization and especially how we manage GPU resources. What's next? What's on the horizon?
Oh man, that's the million-dollar question, isn't it? And honestly, researchers and engineers, they're wrestling with that right now. Like, how do we make the absolute most of these powerful GPUs, especially in virtualized environments?
Right, because the demand is only going up.
Exactly. And that's why you're seeing some really fascinating developments. For example, GPU virtualization. It's already happening.
Now, when you say GPU virtualization, what does that actually look like?
So instead of giving each virtual machine its own dedicated slice of the GPU, which could be a little inefficient. We're talking about multiple virtual machines sharing a single physical GPU, but in a way that's almost, well, it's pretty darn close to native performance.
So less like divvying up a pizza, more like everyone gets their own personal pizza portal that taps into this massive pizza universe.
I like that analogy. It's about making the most of those resources, right?
Yeah.
And speaking of shared resources on a massive scale, we got to talk about cloud gaming.
Right, because that's essentially a form of GPU virtualization, but it's happening in a data center somewhere, right?
You got it. Cloud gaming is a glimpse into this future where our games, our professional applications even, could be powered by these incredibly powerful data centers hundreds of miles away and then streamed like magic to our devices.
It's wild to think about. So someday, this whole idea of local GPU pass-through, it might be like looking back at dial-up modems.
It might be. It's amazing to think about, but that's the thing about technology, always moving, always pushing the boundaries.
Totally. But, even if we do reach this point where everything's in the cloud, there's something so satisfying about mastering these techniques, like knowing how to set up GPU pass-through on your own system. It's empowering.
100%. It's that sense of control, that deep understanding of how your hardware, how your software all comes together. And hey, even if it's not always smooth sailing, even if you run into those head-scratching moments,
Yeah,
the learning process itself is valuable.
it really is. You learn by doing, right?
Absolutely. And who knows, maybe by diving deep into these topics, by experimenting, you might stumble upon something, some new technique, some optimization. You could contribute to the next big breakthrough in virtualization.
Now, there's an inspiring thought.
So keep that curiosity alive, keep experimenting, keep pushing those boundaries.
Well said. And on that note, I think we've reached the end of our deep dive on GPU pass-through and IOMMU groups.
A whirlwind of information, but hopefully it's given everyone a solid foundation to build on.
Exactly. We've talked BIOS settings, kernel parameters, those pesky drivers, even the philosophical implications of virtualizing all the things.
And of course, we can't forget about physically rearranging our GPUs.
That's right. If you're just tuning in now, be sure to catch the full episode from the beginning. Trust me, it's worth a listen.
And for those of you who are already on the GPU pass-through journey, we want to hear from you. What challenges have you faced? What tips and tricks have you discovered? Let's keep this conversation going. Share your experiences. Help each other out.
Absolutely, because in the end, that's what it's all about, right? Learning from each other, sharing our knowledge, and pushing the boundaries of what's possible with technology.
Couldn't have said it better myself.
Well, until next time, happy virtualizing, everyone.